so here we're going to talk about section 3. This will be part 1. We'll talk about just the real basics today of naming and writing ionic formulas and compounds. So first thing we'll talk about is monatomic ions. All the ions we've been talking about up to this point, we're talking about if you're in group 1, you form a +1 cation, etc. These are what we call monatomic ions. Mono meaning 1, okay? Atomic, so mono atom, so one atom within the ion. Later we'll be talking about what we call polyatomic ions, poly meaning more than one, right? So this is pretty much what we've been talking about up to this point, the different atoms forming different ions, and then, but we're going to talk here about the D block a little bit. That D block, and we talked already, that can form several different ions with different charges. It's still a monatomic ion, but there can be multiple charges, okay? And different charges, if iron +2 is in a compound versus iron +3, the compound will have different properties. All right, so we want to make sure we pay attention to that. All right, naming ions. The positive cation has the same name as the name of the element. So a sodium atom, or sodium +1 is the sodium ion. Either way, it's just sodium. But the negative anions, for example, chlorine, becomes a chloride ion. We change the ending to IDE. So fluorine becomes fluoride. Bromine becomes bromide. Oxygen becomes oxide. Right? We change the name ending to IDE. Some ions have Roman numerals as part of their name. We call this the stock system of nomenclature. Nomenclature meaning a naming system. The Roman numerals indicate the charge of the ion. So for iron +2 and iron +3, like we had on the previous page, this is iron Roman numeral 2, and this is iron Roman numeral 3. The Roman numerals, as part of the name, indicate the charge. Yes, Jake?
You pretty much just answered all my questions.
Okay. And I'll give you a cheat sheet tomorrow. Help you a little bit. Alright, so for now, just get out your periodic table, or think about what group they're in, and we'll talk about it. So how do you write a formula for a binary compound? Binary means what?
Numbers.
2. Okay? 2. Binary means 2. So we have a compound that contains 2 atoms. So we're going to write a formula for aluminum and oxygen bonded together. So aluminum forms what kind of an ion? A positive ion. Positive what charge? It'll be a 3. So aluminum, this will form a +3 ion. And oxygen will form a -2. Now, can we have 2 positive ions forming a compound? No, because we need a positive and a negative. Okay? So oxygen forms a -2 ion. So if these two were to bond together, +3 and -2, is that neutral? No. So I have +3 and -2, so maybe I would need another oxygen, so I can't have one of each. Maybe I have 2 oxygens. Is that neutral? No, that's +3 and -4. That's still not neutral. So I would need another 3. That's +3 and -2. That's still not it. How about that? That's neutral. So we have +6 and -6, and that's neutral. All right. So that would be then the formula. We would have 2 aluminums and 3 oxygens in that compound. And those atoms together would come together to make the crystal atom in that proportion. Okay? Yeah.
So it'd be like Al2O3.
Okay, and here's how you do it if you don't have my cool little toy. Alright? So you take, it's called the crisscross method. Alright? So we take the positive, the charge, the absolute values. Don't worry about the positive or negative, but we take the 3 from the aluminum, and it becomes the subscript for the oxygen. Then we take the 2 from the oxygen, and it becomes the subscript for the aluminum. Right?
Oh, wow.
So Al2O3. You write the formula, you use the subscripts, but no charges. You leave the charges off. That's it.
What is it?
Aluminum oxide. Alright, so a couple things we want to maybe talk about, other things we might run into. If we have one like this, let's do magnesium this time. Magnesium, where do we find magnesium? Group 2, so it's going to make what kind of ion? +2. And let's do it with oxygen again. Alright? So this time we're going to do magnesium with oxygen. Is it neutral? It's already neutral. So do I need more than one of each? No. So I don't need to do the crisscross. I'm just going to write MgO. 1 magnesium, 1 oxygen. It's neutral. So if the charges are the same, +2, -2, we don't need to write the subscripts. We just have one of each.
I'm interested in where is this -2 coming from? Why oxygen -2?
It's in group 16. It wants to gain 2 electrons. When you gain 2, then we have -2 charge. That's what that little square in the upper right corner, the little square on your periodic table has a -2 charge. Okay? Well, when I said to get out your periodic table, I really wasn't cheating it.
I remember you saying that.
All right, good. All right, here's one more time we might have a little other thing to worry about. Let's see, lead. Lead can actually form more than one ion, but one of the ions it forms is +4. And let's do it again with oxygen. So lead can form a +4 ion. And then with oxygen. So if we do the crisscross method, and the 4 comes over here, and the 2 comes over here, that makes Pb2O4. Okay? Crisscross, the 2 goes to the lead, and the 4 goes to the oxygen. But if you come back up here and look, if I have this as +4, and this is -2, if I just had 2 oxygens, would that make me neutral? Yeah, that would make it neutral. So would I really need all of these atoms going on here? No. So what we do is we do what we need to reduce. Just like with a fraction, the 2 and the 4 reduce. So PbO2. Yes.
What do you do when the element has more than one?
We'll get to that. I'll talk about that in a little bit. Okay? Basics right now. Yes.
Would magnesium compound be magnesium oxide?
Yes.
And then the lead compound is lead oxide?
Yes. That's what we're going to do next. Okay? Let's do this. Let's name first. All right? Let's do the formulas first, and then we'll get to the naming. All right? So, magnesium and chlorine. So, magnesium.
Chloride.
Magnesium is what charge? 2, and chlorine is -1. So the crisscross, the 2 comes over here, and the 1 goes over here. So what's the formula? MgCl2. Calcium is in group 2, so it's going to have plus 2, oxygen minus 2. The charges are the same, so do we need to crisscross? No, so it's CaO. That's the formula. So if the test, let's see, you might want to do more? One more? Alright, let's do, how about this one? Sodium and sulfur. Sodium is Na plus 1 in group 1. Sulfur minus 2 with oxygen. So the 2 comes over here with sodium, the 1 over here with sulfur, so the formula is Na2S. Right? So, naming. Write the name of the positive cation first. The positive ion always goes first, both in the formula and in the name. Always first. So you just write the name of the positive cation first, and then you write the name of the negative anion, and you're done. Don't worry about the subscripts. Aluminum oxide.